Okay, but they didn't really provide analysis, to be honest, and they didn't really write a mechanism, so I shouldn't have written actually a good analysis here. So actually, my bad, my fault. Okay, so number 5 here. So I have this compound. And I have the other one here. It's going to form Br here. Or sorry, I have a methyl sticking out from here. And then I have another methyl group here. And it says here, it's treated with NBS in the presence of UV. So NBS in UV, and then it's going, what is it going to do? In UV here. So this guy wrote that the bromine is going to attach here. But again, this here would be the incorrect solution. So again, this says here it's not correct, right? So we're thinking of, so again, these here, it says here you don't have to consider stereochemistry, you don't have to draw each atom, so on and so forth. So this solution here, what they're doing is they're actually going to break down what the mechanism behind NBS here is. It's actually a very complicated radical halogenation step. So I could actually walk this. I can walk this over with you. I really don't want to redraw it. It is pretty complicated. But what it's going to do is this here is NBS, so N-bromosuccinimide. What it's going to do is it's going to undergo radical halogenation. So this HV here is the ultraviolet. It's going to break up this N bond Br bond. It's going to form our NBS kind of. This would be our kind of just our nitrogen radical here and our bromine radical. And what this does here, this radical, what these two radicals do is going to break up. It's going to cleave the alkene bond here. So this alkene is going to react with our radical here to form this guy here. So again, I have my hydrogen on. It's going to again basically deprotonate one of these guys here, or it's going to add. Sorry, it's going to add a not deprotonate. It's going to add a positive charge or add a hydrogen to one of these charges here. So as you can see, this is what they did here. The hydrogen charge is now on this carbon here. And what this is going to do, and again, you're going to do then a methyl shift. I believe this would be a methyl shift indeed. And this methyl is going to come and bond here and moving this radical upwards. So let me draw that out for you because this step is a bit more complicated. So this here is a shift, or you can say this in this case, it would be a methyl shift. And why this is a methyl shift is because, again, I have a secondary, this here is a secondary carbocation. What I want to do is I want to make this a tertiary, right? So if I want to make this a tertiary one, it's going to go, again, tertiary is much more stable than my primary here. So I'm going to get double bond here, and then I'm going to get one here, and then the positive charge is going to land here. So this here is actually, no, this here would be a hydride shift, not a methyl shift, sorry. I'm not shifting my methyl. This here would be a hydride shift here, and this hydride is basically from let's see, 1 2 3 4, it's from one of these hydrogens here to make my hydride shift. And then I have my Br, right? Again, I still have my Br radical here. So again, this guy here is negatively charged. So let me use my colors again here. So this here is positive. My Br here is a negatively charged. It's going to come and bond to this guy here. So this site here. So I'm going to get my final product here, looks something like this. And this here is the correct answer for this problem here. So again, Br would not bond here. A lot of students actually fall into this trap because they don't know the mechanism behind NBS and where the carbocation is going to be created. A lot of people just assume it's going to be on this carbon here, but remember there's hydride shifts also exist to provide the most stable carbocation. In this case, the tertiary carbocation, in this case, NBS wouldn't actually deprotonate here. It would deprotonate in, again, it would deprotonate again in this spot and not in this spot here, because this is the secondary carbocation. It's much more stable than the primary carbocation, and then a hydride shift is going to occur to bring this carbocation into a tertiary position for the bromine to then attack and then to form our alkyl bromide here. So this solution here is correct. It's a good analysis because they provided a mechanism behind this bromination here.